Hello, everybody. Welcome to AZ Security. For today, we have a great topic ahead of us. My name is Dinan Paardenkoper. I'm a cloud security architect at IT Impressive. And for today, we're going to introduce the topic from anonymous user to global admin in 35 minutes. Or not. I'm giving the word to two special guests. Welcome to the show and amazing to have you here. Can you introduce yourself, please?
Yeah, thank you for inviting us for this great show, Dinant. My name is Rogier Dijkman. I'm located in the Netherlands and working as a cybersecurity architect for Rubicon Cloud Advisors. And I'm also a 3 times Microsoft MVP on both security and identity. And next to my normal job, I'm also doing a lot of security research and building tools. And one of those tools we're going to show in this session. So I hope you guys will all have fun.
Yeah, and I'm Fabian Bader. I live in Hamburg in Germany and also Microsoft Security MVP. Work for glueckkanja, and most of my day job is to work with our managed SOC operations and help them to automate and improve. And yeah, I will be the good guy today, while Roger will be the red guy or bad guy. Well, let's see how we can move on from that. Yeah, we will have a very nice company today. A look at the Blue Mountain Travel Company. Blue Mountain just modernized their whole infrastructure. They are UK-based travel agency, and like everybody, they are struggling to get into the cloud, but they managed a lot. They moved to Azure App Services for their Arch portal. They did Azure Files for the onboarding, Azure SQL for their HR database. And also they listened to some of the industry advice. They try to avoid secrets where they can and use modern technologies like user-managed identities for their CI/CD pipelines. And of course, they have all that hosted in GitHub. So you can see it's a very modern approach what the Blue Mountain Travel is doing here. And they really did it good if you look at the blueprint. But still, they have something to do, and that is protection. And for protection, they choose the best of the best, Microsoft Defender XDR and Defender for Cloud. In addition, they also spun up some more money and initialized the Microsoft Sentinel suite, the CM solution of Microsoft, and added additional log sources in there that they can then query. So they have Azure activity logs in there, sign-in logs, and even enabled user behaviors and analytics. So they should be very well protected.
Yeah, so today we're going to attack the Blue Mountain Travel, just like Fabian just explained. And we will follow a normal attack chain where we will start off with a reconnaissance to see if we can find any information online about this organization. Then we'll go into the collection phase where we will see if we can enumerate some data. Maybe we can download some data if we're lucky. If we find data that we can use, we might find some information which we can use for both initial access and discovery of our environment. And after that, we'll try to create some persistence within the environment and eventually do a privilege escalation and see if we can become a global administrator within approximately 45 minutes.
Cool.
The session is separated in phases. So phase 1, as just explained, is the reconnaissance and the collection. After I've showed the attack chain, Fabian will go into the detection and protection and preventive measurements that we can take. And after that, we'll pick it up for phase 3 and 4, which will be initial access and discovery. So phase 1 and 2. In this phase, we will do the reconnaissance and we'll do the collection. And we've also added the MITRE attack techniques in below, and we've made them green so it's clear what part of the attack we are executing right now. Let's go to the demo. So here we are. We are in our PowerShell terminal, and we are going to use project BlackCat. BlackCat is a PowerShell module built for pen testing and evaluating the environment on security. It can be used both for the Azure environment and the Entra environment, but also for anonymous enumeration of resources, etc. So our first part of the attack, we'll see if we can find any DNS information about Blue Mountain Travel. We will use the Find DNS Records module for that, and we provide the domain name bluemountaintravel.uk. So if we hit enter, we will see we can find 3 DNS records, 1 A record and 2 TXT records. Which is interesting is the MS record, because that identifies that they are probably using a Microsoft environment to host their resources. The MS record is mainly used to validate the ownership of your domain. So now that we know they've probably got a foothold within Azure, we can see if they have any resources published in Azure that are publicly accessible. As you might know, Azure resources will have a public endpoint. Even if those resources are VNet integrated or only for private endpoint, they usually still have a public DNS name which you can find, even if the resource has a private link. So in this case, we will use the module find Azure public resources, and we will provide the name of the organization. Why the name of the organization? Because we see that they use that a lot within the naming conventions. The name of the organization followed with a prefix or a suffix identifying the type of resource, like SA for storage account and func for function app, or KV for key vault. So in this case, we will use the name Blue Mountain Travel, and we'll use the fast mode. And as you can see, it's really fast. Keep in mind that when you are enumerating DNS records, it can take very long and you can be throttled by your DNS provider. So use this with cause, but it's a really powerful tool, and you're still able to find some information as an anonymous user. Like we just said, we've got bluemountaintravel.blob, which is probably a storage account, which also is the case for the Blue Mountain Travel SA. The other one is KV for key vault. You can also see that to the vault.azure.net domain, and a function app and a other endpoint for the same function app. So we do know that they have a function app, a key vault, and several storage accounts within Azure. My attention will particularly go to a storage account, because sometimes a storage account can have a public endpoint that is publicly accessible. So to do that, we will look if they've got any storage containers that are accessible from online as an anonymous user. And we will use the find public storage account commandlet for that and provide the name of the storage account that we've just found, Blue Mountain Travel SA. So as we can see here, we have found one container within the storage account, which is anonymously accessible, but it hasn't got any files in there. That is interesting, because sometimes a container shows empty, but when you're using the old API of the storage accounts, we are able to find the soft deleted files that are in there, because a soft deleted file within a storage account is actually an old version that is hidden. So to do that, we will run another command that is get public blob content, provide the storage account name again, the container templates like we found previously, which was the empty one, but we now enter the flag include deleted. So let's hit enter and see what happens. Well, here we go. Apparently within this templates folder, there was an onboarding welcome email, which has been deleted. We can see the version ID of when it is deleted and the full path to download the file. Well, downloading information anonymously from an Azure environment is always interesting. So let's use the next command for that. For this command, we will use the get public blob content. Again, we provide the storage account name, the container name templates. We will include the deleted file. And as the output path, we will download the files to the loot folder. If you provide the switch download, it will actually download the file. Here we go. So that only took a second. But we have now downloaded the file. Let's go into the loot folder. And let's see if we can invoke the item that we've just downloaded. Invoke item, which was the onboarding email. So what we can see here is that we have found, and we'll zoom a little bit in, a template email that this organization, Blue Mountain Travel, uses. We can see it's a template because it starts with dear first name. It's usually not a name that you will use if you send an email to someone, but it seems to be a placeholder. The other interesting information that we will find within this file is that they use personal folders that start with docs and then a first name dash last name, which is a good indication that they are probably using something like Azure Files and use the first name and the last name of the users to provide information. The other thing that we see here is some links to different files for the user that's being onboarded. If we hover over the file, we can see there's a very long URL in here. It's hard to read in this screen, so I'll also open up this file in PowerShell to see if the content is easy to read. We will use the standard PowerShell command for that, get content, And again, we will provide the just download onboarding welcome email.email file. Well, here's the email as text. It isn't easy to read, but it will provide us a bit more information about the links that are in there. Here again, we will see the Blue Mountain Travel SA storage account. What we see here is that there's a folder in that storage account, which has a first name and a last name with a welcome file in there. That's also the case for the other files. Good to know that they're using Azure files. What makes it even more interesting is that they are using a SAS token for the authentication against Azure files. This can be very valuable information. So let's copy this value and see what this SAS token can do. I will clear the screen for a second and use the BlackCat command read SAS token. The only thing that we need to do here, just paste in the SAS token, hit enter, and now we can see what the SAS token can do. We can see that it has account level on the storage file. It's got service level API, container level API, and object permissions, and it can read and list all files within the storage account and within the storage containers. The other interesting thing is the expiry time of the SAS token, which states that it is available up until 2028. We see this a lot in practice, that people are creating SAS tokens with a very long lifetime and just don't realize that it's very dangerous because it can be used for a long time if somebody gets hold of this SAS token. So let's put that SAS token into a variable and see if we can use that to authenticate against the Azure Files environment. So temporarily make a SAS token. Here we go, hit enter. Now it's in the PowerShell variable. And let's also create some other variables in here. We will create one for the storage account and we will use one for the file share, just to make it easier for the next commands. Here we go, storage account Blue Mountain Travel SA and the file share docs, like we've just seen in the onboarding email. Here we are. So the next PowerShell command that we're going to use for this is the BlackCat command get file share content from the storage account. From the storage account variable, the file share is the file share name that we've provided, and we are going to provide the SAS token. Hit enter. What we see now is that we can see the user folders indeed. And again, it's the first name and the last name. Bridget Jones, Bruce Banner, Ethan Hunt, and a lot of other famous people are working for the Blue Mountain Travel Agency. The other interesting folder in here is the config folder. This can contain some important information. First of all, let's download some information about the user and see what kind of information Blue Mountain Travel provides to its new users. I will quickly clear the screen and paste in the next command. Again, we will get the file share content for the storage account, the file share, and now we provide the path Peter Parker. So we're going to download the files of Peter Parker. We'll provide the download in there. Here we go, and we've downloaded 4 files. The welcome HTML, the training schedule, IT equipment, and first day instructions. These are just like the links that we've seen in the previous email that we downloaded from the templates folder. So again, let's see what is in this emails. I'm going to invoke the item from the folder Peter Parker, and we'll look into the welcome email. Here we are. This is the welcoming email that is probably being sent to all the users. We can see several things in here. We welcome Peter Parker, so we know we've got the right file from the right folder. We now see what his username is, peter.parker@bluemountaintravel.uk, and we can see what the temporary password is for this user. It's a common issue that organizations are using a standard password for all the new users, especially passwords like this, travel@2026, exclamation mark. Not a really strong password, but always easy to remember for your new users. Good to know. Now see what more information we could pull from this environment. If you remember correctly, we also found a config folder. So let's add the command to download the config files. Get file share content again, but now we provide the path config. Provide a SAS token again, and we will download these files. Here we go. We've now also downloaded a file called app.config.back. That seems interesting. It seems like a backup file of a app configuration. Let's see what's in this file. We will use the get content. Get content. It was in the config folder and the name was app config.back. As you can see here, we've got some sensitive information within this folder. We've got the tenant ID of the organization, a subscription ID, a client ID, and a client secret. We also see some information about the storage account, how the storage accounts are being organized, and something about the app service. If you remember correctly, we found several resources of Blue Mountain Travel, a key vault, a function app, and several storage accounts. This is probably related to one of the app services or function apps that Blue Mountain Travel has been using. Back to you, Fabian, to explain some more about the protection measurements that we can take.
As you have seen, Roger was able to enumerate a lot of the public information that is available. And we also seen that Blue Mountain Travel has some detection built in. They enable Defender for Cloud, for example. And in Defender for Cloud, for about $10 a month, you also get storage account protection. And what happens if you enable this is basically you will get this alert. Publicly accessible storage containers have been exposed, meaning somebody scanned this storage container that is publicly available. But of course, this is normal on the internet that somebody is trying to do that. And if you might want not to spend those $10 per storage account, you can also go for a custom detection. But in this case, you need a storage diagnostic logs. But what we built here is basically a potential storage enumeration or brute force attack, where we look at the same behavior pattern. Somebody is enumerating a lot of your content, gets a lot of 404 or error messages in the web, and suddenly they hit a return code 200, meaning success. And to do this, you have to deploy this detection logic, which you can find on my GitHub. I will later also get a link to that. And you must make sure that all your storage accounts send the logs to the correct Sentinel workspace. And for that, as you can see here, you have to configure the diagnostic settings on the storage account and make sure that the audit logs and the all logs are sent to the respective Sentinel workspace. This makes sure that all the storage write operations and everything are getting sent to this CM solution. One other thing that we can build if we have the capabilities and the logs now in Sentinel is a detection for anonymous retrieval of Azure Blob versions. Roger mentioned this old API that allows you to see old versions of files. That's something that you definitely have to put in the URL that you are requesting. And this makes it easy to detect and to alert. And since normally nobody will look for old versions on public storage accounts, that's definitely something you might want to consider. And if you find somebody is doing that, maybe block the IP address and no longer let them access the files, and also make sure that they don't have access to sensitive files. And hopefully you don't have sensitive files on there. Next is another detection that we built, and this is successful Azure storage file access from unauthorized geolocation. If you decide there is some data that you have to expose through a SAS key and you cannot use a more restricted method like user identities or something like that, you at least can try to pinpoint the geolocations that your users will use it for. And for Blue Mountain Travel, that might be Germany, UK, and everything else should create an alert. And if we look at the prevention side of the house, we now have detected a lot, but normally we don't want to start at detecting, but we want to go a bit more left in the protection measurements. We want to do this through Azure policies. And Azure policies are a guardrail that you can deploy in an Azure environment that makes sure that if you deploy a new resource, that this resource adheres to certain restrictions that you defined. And there's a lot of policy definitions already available that you can just assign to your subscriptions, or even better, to management groups. And one of those policies is the configure your storage account public access to be disallowed. This does not help you if you already have those, but at least when you deploy this, you will then later on see all the storage accounts that are not applicable or where the policy would run against an error, and then you can fix them. Another one is in Defender again, the security recommendations. And there you can also see, hey, I have certain security recommendations. One of those is also called storage account public access should be disallowed, meaning if you have Defender for Cloud in the CSPM variant, so the Cloud Posture Management variant, then you will also get this information, of course, not only for one resource, but for your whole environment, for your whole subscription where you have enabled it. And you can then go through the list from critical to low and decide which of those you want to mitigate. Of course, some of them you definitely want to mitigate, like publicly accessible, if that is not wanted, or something like the shared key access that we saw is also problematic. But maybe you don't want to use a private link connection because you want to use the public internet, then the last one might not be the one for you to implement. What's a bit sad is normally we should have also an alert for sensitive data on this storage account. Because, as you have seen, we had this backup file with all the client secrets for the application in there, but somehow this didn't work in our environment when we were trying it out. So it did not find any sensitive data. Hopefully this is fixed in the future. And now back to you, Roger.
Thank you, Fabian, about the prevention and detection mechanisms that are available within both Azure and Defender for Cloud. Let's go back to phase 3 and 4 indeed. This will be the next part within the attack chain. We will see if we can do the initial access part and the discovery. Initial access is where we're trying to authenticate with the credentials that we found, and discovery is the phase where we are trying to look around in the environment as an authenticated user. Hopefully the credentials that we found within the app config file will work to log into the environment. So for the first part, we will provide the parameters that we're going to use that we have found within that app config file. We provide the service principal ID, the tenant ID that we are going to authenticate against to. We're going to use the client secret and the subscription ID. By the way, the client secret that's in this file or in this recording will not be available after recording anymore. So don't try to be smart and try to log in using these credentials. Of course, it won't work, or we will find you.
Watch out.
We're going to use the connect service principal function from the BlackCat module. And we provide the parameter set that we've just created as the parameters to log in. Here we go. Waiting for a couple of seconds. And now we can see we are actually authenticated as the HR onboarding legacy deployment. If you remember the story correctly, Blue Mountain Travel was migrating from an old system to a new identity system. This is probably the part where they use the old app registration for the automation and deployment of the resources and maybe for synchronizing the users. So now we've got the first foothold within the organization. Let's see what kind of permissions this has within Azure. We can use the get role assignment for the current user to see what permissions the current identity has. Here we go. The power of this function, get role assignment, is that it's doing a batch query that is both harder to detect and it's being executed at the tenant root level, which makes it extremely fast. We've ran this within bigger environments with about 200 subscriptions. We had about 30,000 role assignments, and it took some bit under 2 minutes to get all assignments from this environment. Really fast and really powerful, both for a red teamer and a blue teamer in this case. So what we can see from the output of this command is here we are indeed authenticated as a service principal with the principal ID. We already knew that because we had it from the config file. What makes it interesting now is that we see that this identity has the contributor permissions on a subscription. I won't read out the subscription ID, but being a contributor on a subscription is a very powerful role to have. As you might know, as an Azure expert, if you have contributor permissions within an environment, you can change almost every resource that falls within that subscription or the scope that you have the permissions to. So the next thing that we want to see is if this organization is using managed identities. The function get managed identities does the same as get role assignment. It's running from a tenant root. So these are all the managed identities that are available within this tenant that we are logged in now, specifically the user assigned managed identities. These identities are frequently used to provide access to other resources that you don't want to give to a user. So for an example, if we have a virtual machine and this virtual machine wants to have access to a key vault, we can use the identity of this virtual machine to have access to the key vault and retrieve the keys to the secrets that are in there. Very powerful and very useful because we don't need any passwords anymore and we don't need to give any users permissions. The downside of that is basically that Microsoft is giving a system assigned managed identity by default to resources where you enable it. The other option that you have is a user assigned managed identity, which is an identity that you create and that you can attach to that same virtual machine. Now, if you delete that virtual machine, recreate it, it would get a new system assigned managed identity. But because we're using a user assigned managed identity, we can attach that identity and the same identity will keep access to the key vault, which is very powerful. The other thing that a user assigned managed identity is being used for is for federated authentication. We can use that to trust other platforms to deploy resources within this Azure environment using the federated trust to an external environment, like a GitHub, for example. So we were starting off with Blue Mountain Travel and the migration of the user access management system. So let's see if the UAMI HR CI/CD automation has got some permissions that are interesting to us. We will use the get service principal permissions commandlet for this. The service principal ID that I've provided is the service principal ID that was shown in the previous table for the UAMI HR CI/CD automation, which started with 197. What we can see here, if we run the get service principals permission commandlet, it will show the name of the service principal that we just called. And down here at app permissions, we can see it have Microsoft Graph permissions, user read write all, group read write all, app role assignment read write all, and application read all. This seems a bit like a misconfiguration for an identity synchronization solution or an automation account. Creating users and creating groups sounds logical. Reading applications, yeah, that can be okay. But app role assignment is a really powerful function to have, or API permission to have, to be more specifically. But we see a lot of misconfiguration because people think that they can use this to assign roles to specific users, which sounds logical to assign it to a CI/CD automation pipeline for a user identity system. Now, we know that this is used for automation. So this resource probably has a federated credential, but we can check that using the get federated identity credential commandlet. Here we provide it again, get federated identity credential, and we provide the name of the UAMI. Hit enter, wait for a couple of seconds. And what we see here is that they indeed have a federated trust with GitHub. Specifically, they've got a repo called Blue Mountain Travel. They've got a repository, that's the organization. They've got a repo in there called HR Onboarding Portal, and we trust the main repo of that GitHub. This means that they are probably using GitHub for their automated deployments to Azure. What we are going to do now is very interesting. Because we know that they have federated credentials, we're going to see if we can fetch a token from that federated credential. As said previously, we need either a federated identity trust or federated trust, or we need to attach this user assigned managed identity to a resource to use for authentication. Within BlackCat, we've got a function to actually pull out the access token of a user assigned managed identity without attaching it to a resource. Sound interesting, right? What we've done here, we've provided the resource ID of the UAMI, and now we are going to use the commandlet invoke Federated Token Exchange. What this does, it creates a temporary federated identity trust to a storage account, which is the BlackCat OpenID Connect blob storage account, and it's got an OpenID Connect folder in there. Once we hit enter, the function will start to run. It will add an extra federated credential, and within a couple of seconds, you can see that we got the access token of this user-assigned managed identity. That is really powerful, because now we can actually authenticate in PowerShell as the user-assigned managed identity without needing a resource or anything else. I will run the function again and put the access token in a variable. Here we go. We call it $token is and run the command again. Here we go. Now we've got a graph token. As you can see here, the scope is graph.microsoft.com/default. Let's see if we can authenticate with this new token. Quickly clear the screen. And we use the commandlet connect graph token with the access token of the user-assigned managed identity that we just fetched. And as an endpoint, we'll use the Microsoft Graph in this case. Here we go. As you can see, we are now authenticated as the user-assigned managed identity that we found previously. And this also means that we have the permissions of this user-assigned managed identity within this current PowerShell session. So now we can actually do the user read-write-all, group read-write-all, app role assignment read-write-all, and application read-all actions with this identity. The next step that we can do here is see if we can add ourselves more permissions. As said before, if you have the, where is it again? App role assignment read-write-all permissions, you can actually add permissions to other resources within Entra. What we will do now, we will try to elevate the permissions of this user-assigned managed identity that we are logged in with. Here we go. We provide the user-assigned managed identity ID, and now we will run the next commandlet, set managed identity permissions. Within the set managed identity permissions, we provide the service principal ID of the user-assigned managed identity. We say we will provide permissions on a Microsoft Graph endpoint, and we want to add the application read-write-all permissions. Let's hit enter. It takes a couple of seconds. And now we've elevated the permissions of this user-assigned managed identity. It now actually has got application read-write-all. That went pretty easy. The next step that we're going to do is add some more permissions. We'll clear the screen for a second. Set managed identity permissions again, and we will also give it role assignment.read-write-all on directory level, which actually means that we can assign Entra roles to other identities, including ourselves. Here we go. We now also have assigned the role management.read-write-all directory permissions to the user-assigned managed identity. Back to you, Fabian, for the next phase.
As you have seen, we are now very deep, not only in Azure, but also in Entra, and a lot of systems and identities have been compromised. But what can we do on the detection side? First of all, when we add new federated credentials to a managed identity, we can monitor that. There's basically two changes. One is within Azure for the managed identity itself, and one is in Entra, because you always have this part where the service principal of the user managed identity is also changed. And we definitely want to make sure that only allowed OIDC providers like GitHub actually are being used and not some storage account out in the wild. And if that happens, we definitely want to get an alert on this. If you want to do this, also make sure that you send all your Azure logs to your Sentinel. One nice thing about that, Azure Activity is a free log source, meaning you do not pay for the log ingestion of those logs into your Sentinel, so it's basically a no-brainer to put them in there. Another alert that is also very important is service principal sign-in from new country. So again, we are using location to make sure that some application that is always coming from the same region is not coming from somewhere else suddenly. Because if that happens, you definitely have a problem. The other one is the app role assignment enumeration. Your normal service principals, they will just work. They will do whatever they are tasked to do, and that's all nice. If a service principal is suddenly reaching out and asking for app role assignments in your environment, that's definitely not okay. Or at least for many of the applications out there, it's not okay. Depending on what the application is, it might be, but those you can definitely then allow this in this query. But for all the others, if they suddenly start to look around, you definitely should look around as well. And then, of course, we also built something that will detect the BlackCat enumeration. So if you run through BlackCat and just give it a go on all the app assignments and everything, we have built a unique fingerprinting that detects that. And also we can use the user agent if you are lazy and detect you. But what we really want is never let this happen in the first place. So let's have a look at the prevention part. One way to actually block any service principal from signing in, if they have either a risk assigned or they are not coming from the IP region that you want them from, is using conditional access, just like with your normal users. Sadly, it also comes with a license attached, but that's definitely something where you get your money's worth, because protecting those service principals, it's a very important part. The next one that's coming is Azure policies. We just talked about you can detect which federal credentials or which issuers are allowed. We cannot only detect this, but with Azure policies, we can prevent it. So in this case, if we had this policy applied and we would only allow certain issuers like GitHub, then the attacker would be stopped there. They will try to add their own issuer, but then it basically is like, okay, you cannot do this because there is an Azure policy. And remember, the attacker in this case only had contributor, meaning that they cannot mess with an Azure policy. For that, they would need owner permissions or user access admin to elevate their permissions. But what if they use GitHub? We've seen another OIDC, but we can also be like, okay, we are using GitHub, but we want to lock it down to certain repositories. And that's definitely something you should do, so that not somebody is using some personal repo on GitHub and then using the actions there. So an attacker could also go that route. With this Azure policy, you can block that as well, making sure that only your company's organization in GitHub is allowed and trusted for your user-managed identities. And at last, you can also configure something called the application policies in Entra. There you can change different things like block password addition. So password in this case means secret. So nobody is using an app secret from there on forward. You can also restrict the lifetime of your secrets. I think that is definitely the one you should aim for, that if you have to use secrets, at least have a rotation there, that if they are exposed and you don't know it, that after some time, this will definitely be remediated automatically. And the last one is also block custom secrets, something a lot of people luckily don't know anymore. You can really just set your own secret if you are using the API, meaning stuff like password 123 was a possibility for service principals, and now you can also block it. And that you should definitely do. Roger, let's get to the last and final bit of your attack. I'm really nervous how far you can get.
Yeah, you should be, Fabian. Again, good explanation about the prevention and detection possibilities that are available. So we went through the reconnaissance phase as an anonymous user. As an anonymous user, we were able to collect some information from a Azure storage account in this case. That information was very valuable and could also be used for the initial access, where we authenticated with the user or with the app registration, like we did. As an authenticated user, we were able to discover the Azure files that was also attached to the same storage account. And as an authenticated user, we were able to download even more files. Then we went into Azure and looked for the information that we could find within Azure. There we found a very valuable user-assigned managed identity that we could use to elevate its own permissions. So let's see how we can continue from there. Persistence, privilege escalation, and maybe game over. So we are back in the terminal. If you can remember, in the previous step, we've added some permissions to the user-assigned managed identity. The next step that we should do is get a new access token of this user-assigned managed identity that includes the new permissions. So to do that, we first need to log in as the service principal again. Why the service principal? Because the service principal had permissions in Azure. And the user-assigned managed identity did not have any permissions within Azure, but only had permissions within the Entra environment. So provide the parameters again. Again, the password will be expired after the session, and we will connect with the service principal, including the parameter values. Here we go. We are re-authenticated as the HR onboarding legacy deployment, the account that had contributor permissions within Azure and was capable of reading and modifying Azure resources. The next step that we will do now is again get a new access token of this user-assigned managed identity. So we will paste in the value, and now we've got a new access token. The other thing that we could do, let's run it again, is provide it with an extra parameter, which is called cleanup. What it will do right now is set a new federated identity credential, fetch the access token, and once the access token has been retrieved, it will clean up the federated identity credential. So if somebody looks into Azure, they won't see any federated credentials that they don't know. This will take a couple of seconds longer, and here we are. Now we've got the new token within the token variable again. Let's use the token to authenticate again with the connect graph token commandlet. We'll provide access token again that we just fetched from the user-assigned managed identity, and our endpoint again is the Microsoft Graph. Here we are. We are now re-authenticated as the user-assigned managed identity. What's more interesting is to look what permissions we have. So what we will do now is put this between brackets and request the roles to get a better overview of the roles. What we can see now is that we have the user read-write all, application read-write all, group read-write all, and app role assignment read-write all. These were the permissions that were already set to the user-assigned managed identity. But now we also have the role management read-write all and the application read-write all permissions, which means that we are now able to create new resources with Entra and provide role assignments to this newly created identity. Within the BlackCat module, we've got a function called add Entra application, which will by default already have a lot of permissions. You can change the permissions and settings using the parameters within this module or within this commandlet. In this case, we'll just run it as is with the display name MSPIM, which means that we're going to create a MSPIM application within Entra, which is funny because you would expect that MSPIM is a reserved name. Well, it actually is if you are using the UI. So if you go to entra.microsoft.com, you probably won't be able to create an MSPIM application. But if you do it through the API, we've got no restrictions. Hit enter, and now we have created a new MSPIM application. The next step is that we're going to set some credentials to this newly created app registration. Why add credentials? Because this will create some persistence. We have an app registration, and we will add a new password to that that's only known by us. Oh, my mistake. Instead of the service principal ID variable, I need to provide the service principal ID. So let's do service principal ID is, and we will get the service principal ID. Here we go. Copy the value, paste it in here, hit enter, and now we're going to run the function again. Here we are. We have now set a new credential to the MSPIM application within Entra. That is cool, because now we have created persistence and a backdoor into the environment. Let's see if we can use this to authenticate against the environment. Well, we use the connect service principal commandlet again, like we have used it before. But in this case, we need to provide the application ID of the MSPIM application. So we're going to copy that value, copy, paste it within the service principal parameter, and we also need to provide the new secret. So we're going to delete this. We're going to copy the value of the previous commandlet, which shows the secret text. Here we go. Copy. We'll paste it here, hit enter. And now we are authenticated as the MSPIM application. Cool way. So what we can do now is see what permissions our current user has. So we will do get Entra information for the current user, hit enter. As you can see, we are now global administrator. It's now finally game over within this environment.
So if you have read our title correctly, we are now over 45 minutes, so I'm good. But still, we are at Global Administrator, and a lot of the stuff we were able to detect, or we could have prevented if it would be set up correctly. But let's have a look at the last part, Global Administrator. What happens then? Of course, we also have a few custom detections for you in the hand, but let's move over to what actually happens in the moment where Global Administrator is assigned. Because you will get a Microsoft email. And as you can see, it's a nice information. Hey, there's now this role assigned to somebody, and this happened then and then. This definitely is the reason why you should have active email addresses, and you can use plus addressing in there for your global administrators in your tenant, and make sure that you monitor those email boxes as well. But since Blue Mountain Travel had also a SIEM, they also got this nice custom alert. Service principal added to global administrator role. This basically just checks as soon as a service principal is added to the global administrator role, which is of course not something normal. We also have another alert, privileged role assignment outside of PIM, which makes sure that we get an information if somebody is not using PIM to assign such a high privilege role, which we definitely should do. And only the break glass account should have standing permissions for global administrator in your Entra environment. But in the end, we were able to see that a lot of this happened because we didn't use the full protection mechanisms, and only detection is not enough. So if you want to make your environment really safe, make sure that you have detections in place for the moment something is really wrong, but also look into how you configure it correctly, that such configurations are not possible or that such attacks are stopped in an early stage. One of the tools that you can use in there is the Maester tool. It's basically a free best practice analyzer for your whole environment. There's a lot of recommendations in there from the community. It grew over 100 tests, and I think we are now close to 150 tests, not only in Entra, but Intune, and even Exchange. So the community came together and built a really, really good tool that helps you for free to improve the security in your environment and make sure that something like this is not happening to you.
Yeah, thank you for that, Fabian. And I'm glad we were able to gain ourselves global administrator within the Blue Mountain Travel environment. As said before, the credentials that you've seen within this video are not valid anymore, but we've got a nice challenge for you. The bluemountaintravel.uk travel website is actually publicly available and you can use it. I won't book a flight or a hotel there if I was you, because you won't get a trip and I will get your credentials from that environment. More fun for me, but not for you. But what is actually the challenge? This website has about 60 vulnerabilities, including a SQL injection vulnerability. And we've created the challenge that the first one that is able to gain itself to global administrator permissions using this website will get 1,000 euros of Azure commit for the upcoming year. So I hope you will accept the challenge and send me a notification once you've been able to grant yourself global administrator within my tenant.
And with that, thank you so much. Also, thank you, dear Anton, to host us today. It was a real pleasure to be here.
Yeah, awesome, guys, to have you here. A great demonstration, a great story, best practices which are shared. So I really love this, and amazing that you both are here in this session. Thank you very much. For everybody at home, I want to thank you very much for listening, for watching. If you have any thoughts, leave them please on the thoughts below. And otherwise, till next time, take care.